Hi guys, this is lesson two or part two of our discussion on algebraic expressions. Okay, we have discussed very fundamental things in the previous lesson. If you have missed it, I urge you to watch it because the stuff we discussed there are going to feature in along the discussion as we continue. Right, we want to quickly again recap from what we did in the previous grade, that is grade 9. So let's think about this. If I had a product, a binomial, an expression x plus y all squared, and one of the things that I would usually do in that case is to expand this. Okay, we get this from laws of exponents. Okay, you know that x squared means x times x, or maybe I should not use that. I should just say x dot x. You know that, okay? So this is the reason we do this thing here. So you know I've got to rewrite that thing. Then you guys were taught about this thing called FOIL, okay? You know what FOIL is. I'm not going to insult your intelligence in that. So I've got to multiply this x by that x there first. That gives me an x squared. I've got to multiply this x by that term there. That gives me an xy. I've got to multiply this one by this one. Yeah, you can write it as yx, but you know it is xy also. And this one by that one, finally, this is y squared. Now, we look for like terms at this point, and you can see these are like terms. Why? Because of the following. There's an x here and there is an x here, and the powers of x are equal, okay, or the exponent. There is a y here, and the exponent is the same as that one there. That's why we conclude that those two are like terms. So I've got to add those and say 2xy plus y squared. So very simple, procedural, straightforward. Let's take another one. What if I wanted to find the difference? So let's suppose now I did that. Okay. Now, this again, same principle. This should be x minus y into x minus y, right? And then again, I do the foiling thing. This has to multiply that. This thing here has to multiply that. This thing here, that, and that thing there. Therefore, I'm going to have here x squared minus xy minus yx. Now be careful, this is a negative times a negative. It's a positive, that's got to be a y squared. So then that's x squared. Again, this is like terms, signs are the same. We must just add and keep the same sign, plus y squared. And that's it. Very simple and procedural. But guys, I don't know. Do you see a pattern here? Do you see a pattern here? Maybe let me write this nicely down in black. If I have x plus y all squared, check what I get. I get x squared plus 2xy plus y. And if I have x minus y all squared, then what I get here is I get x squared minus 2xy plus y squared. What do you notice? Is there a pattern that you guys notice here? I hope you do notice something. Check. All I did here was to take that first term and square it. Then what I did here is to multiply this term by that term. So this thing here is a product of xy. And then just multiply that by 2. And then take that also and square it. Let's see if that's the same thing that happens here. Of course, this is supposed to be squared, my bad. Here is exactly the same thing. I squared this thing. Then I multiply x times y. It is xy. Then I just multiply it by 2. And then finally, that becomes a y squared. So notice something. Whenever, guys, you're going to have a bracket in this form, an expression in this form, instead of expanding and making yourself tired, you can simply do this, but be careful to find the product of the two terms and check what my middle sign is. This is plus, that's plus. Here, this is minus, and that's minus. So that's another very key thing, important, that you need to to get. Or actually, if that is confusing for you, we can write a general thing here. So generally, whenever you have an expression of this nature, all that you do is you can actually take your first term, so first term, and then square it, add 2 of what? The product, okay? And then add again the last term squared. Let us see if this will work for other expressions. Let us put this thing here to the test, okay? Let's test it. Suppose I have x minus 1 all squared. Then what I really have, or can simplify this into, is to say, well, I'm using this general formula. I must say x squared plus, I must put a 2 here. Now, what is x times negative 1? Yes, that's the important part. Is negative 1x. It's fine if you write 1x, that's okay. Then I must say what? Plus, what is minus 1 squared? It is 1. So therefore, this thing is actually x squared. Now you simplify there. This is minus 2x plus 1. That's how easy and straightforward this is. Guys, if you are still doubtful, test it with anything. Say x plus 2 maybe here, all squared. Go ahead and check this using your standard foiling procedure. You will see that it will work. Of course, this is a special case, and what makes it special is because of that, okay? That thing, this whole thing can be put into that. And why let that, guys? This is where now I would like to just throw this a little bit. It will follow in the next video. This is the difference actually between simplifying and factorization. What we were doing here actually, when we are moving from this step to that step down here, we were actually simplifying. Okay? But if they say factorize, then they mean move from this step back to that step. That is factorize. What are we learning here? When you simplify, you are taking something that is made one thing, you are making it into different things. When you factorize, you take the number of terms, you are grouping them, you want to make them one term. So simplifying reverses factorization, or we can say factorization reverses simplifying. That is a very important observation that I need you guys to make. Let me repeat. Simplifying is the reverse of factorization, and factorization is the reverse of simplifying. When you are simplifying, you are taking basically something that is already factorized. Okay, let me give you another example here. When you are simplifying, you are taking something that is already factorized, okay, and you want to write that as something that is not factorized. That's what you are doing when you simplify. When you factorize, you are taking something that is simplified and you want to make it one term. Finally, another way to say it, simplifying. Repetition is very important for me so that this thing can sink. When you simplify, you are taking one term, making it basically different terms. However, it is important to note that sometimes you can simplify and end up with one term. When you factorize, you are taking more than one term and you want to group that into one term. You are taking more than one term, expression with more than one term, you are making it one term. So in other words, in mathematics, this is how we cheat. And what is the objective of cheating is to make one thing one term. We either put brackets, and that's why there is brackets when we factorize, or we multiply, okay? Or you can say factorize. That's it. That's it. And remember, basically brackets is the same thing as multiplying. So let's check this. So here the question will say what? Simplify. So when we simplify this thing, again, FOIL, yes, I hope you got that. I'm gonna have to say this thing by that thing, and this thing by that thing, and this thing by that thing, and that thing by that thing. In this case, guys, this is very different from that. So this thing here is not like that. So don't try that. This one is already like this. So we gotta just work it out. This thing is gonna be 4x times 3x, which is going to be, okay, maybe let me write it. 4x times 3x. Okay, there's the first step that I took. And I'm gonna say plus because positive here and positive is positive. And I'm going to say 4x times 1. And I'm going to say negative and positive is negative. Then y times 3x. Y times 3x. I'm going to say negative and positive is negative. Then I have y times 1. Very important from here is that whenever you multiply expressions or a term with another term, it is important to consider this what I call S and M. Signs, numbers, letters. Okay, that's very important. So let's see. Now, let's multiply again. Signs, positive, no worry. 4 times 3, 12. X times x, x squared. Plus, what is 4 times 1 is 4. Then I just have x. Minus, what is y times 3x? It is 3xy. Minus y. Now let's check. Are there any like terms at this point? I hope you are not thinking that there are like terms because this thing here is not like term to that. There is an x here, there is no x there. Okay. And in the same sense, there is a 4x here, but there is no y there. So we're going to leave this thing as it is. We have simplified it. We don't have to force it to be one term. Guys, by now, you should have outgrown that. Finally, final note that I'd like to close this video with is back to my problem there. Guys, I see a lot of kittens, puppies being killed. I have taught this. Now, I don't expect you to look at this thing and say, well, this is going to be x squared plus y squared. Please, no. You see here what this should simplify to. The same thing here, guys. I have shown you what this thing simplifies to. Never, never write it as x squared minus y squared or x squared plus y squared. Please don't try that. I'll faint if you do that. Okay, I'll stop it here and I will continue in the next video. And of course, you can tune in so that we move nicely together. Cheers.